going to talk about factoring polynomial functions. The reason we need to do this is because ultimately we're going to need to solve polynomial equations. But the biggest issue in solving polynomial equations is being able to factor them correctly. Because once you have them factored, we'll apply the zero product property that we've now used in a couple of different things. So that's what we'll ultimately be doing. But before we can get there, we need to be able to factor polynomial functions. If we look at this first one, x cubed plus 8, this is what's called a sum of two cubes. X cubed is a perfect cube, and 8 is also a perfect cube. There's a special formula for these. The sum of cubes, we have a plus b, where a and b are the first, a is the first term, b is the second term. And then the second thing is we have a squared minus ab, and then it is plus b squared. That's our formula that we'll use here. A is x, b is 2. It's the cube root of each of those. So as we look at this, this is equal to x plus 2 times the quantity x squared minus 2x plus 4. Now the common thing to think is that, hey, this is going to factor more. It's not. It's not going to. I know this is a perfect square and that's a perfect square. However, this middle is not does not fit our ability to factor a trinomial there. It will not be able to factor. So ultimately, this is the final answer. The difference of cubes has a similar formula. There's just a minor difference. We again, this time, we're going to have a minus b. Then we'll still have a squared on the inside, but now everything becomes plus. So it's a squared plus ab plus b squared is how this one works out. Again, a is the cube root of the first, and b is the cube root of the second. So for this example, our a is 2x, and our b is 3. So when we go to factor this, 2a minus 3 times a squared, that'll give us 4x squared, minus 6x plus 9. Okay, and again, will not this trinomial will not factor. So that's it. That's all these are for the sum and difference of cubes. You'll get more comfortable with these formulas, so to speak, as we do more and more of the examples. This is essentially what we need here is our formula. Just so you have this written down, the sum of cubes, this is a plus b times the quantity a squared minus ab plus b squared. That formula we just used. And then the other one we just used as well. A minus b times the quantity a squared plus ab plus b squared. Those are the formulas for the sum and difference of cubes that we'll see those. We'll see those a lot. So you'll get better with those as we move on. Factoring by grouping. Okay, we've already done this a little bit. Whenever we were factoring some quadratics and we used one method, we did factoring by grouping. Okay, remember, things to remember, our parentheses should have the same thing. And that's one big thing to remember here. So if we look at these, we're going to factor out. First thing I guess we have to do is we have to group have our groups here. I'm actually going to rewrite this. I don't like the way it looks. We're going to rewrite this just a little bit wider here so we have a little more space. X cubed minus 2x squared. And this is the one time I'll tell you to do plus negative 9x plus 18. All right, I think it really helps you out here. So we have our first group and we have our second group. What we do is we look for the greatest common factor of the first two monomials, and that is going to be x squared. So we factor out x squared from here. So x cubed divided by x squared will give us x. 2x squared divided by x squared will give us minus 2 there. The reason I want you to do plus or minus is now we're actually going to factor out negative 9. It's really important for our signs and our parentheses to match up. We get negative 9 times the quantity x minus 2. And again, we have the same thing in parentheses, which is good. We factor those out. So we get x minus 2. That leaves us with x and minus 9, or x squared. So then we have x squared minus 9 left there. This one happens to work out where this is a difference of perfect squares, so we would need to factor that a little bit further. X minus 2 stays the same. Remember the difference of perfect squares. Those are the ones where we do x minus 3 and x plus 3, and we are done. So again, make sure we have the same thing in parentheses. We group appropriately. These are the greatest common factors of the two groups. Factor those out. Big thing we'll be using. So if we look at this first one, we're going to factor it by grouping. These are the last two examples we got today. So this first one, we're going to look at factoring it by grouping. So again, I'll rewrite it. X squared, y squared, minus 3x squared, plus negative 4y squared, plus 12. We'll have our two groups. Okay? So if we look at this first set of parentheses on the left, the only thing they have in common is x squared. So we'll factor that out. That leaves y squared minus 3. Greatest common factor here is negative 4. We'll factor out the negative 4. That will leave us with y squared minus 3. So again, I have the same thing in parentheses. The same thing in parentheses. So that's good. We'll factor that out. Y squared minus 3. So this is gone. This is gone. The only thing that's left is x squared and minus 4. And those will go in our parentheses there. And like that first example, x squared minus 4 is a difference of perfect squares. So we'll have y squared minus 3 times x minus 2 times x plus 2. So that's our final answer for that problem. Now if we look at this next example, there's only 3 terms. It is a trinomial. The last two that we factored by grouping, we have had 4 terms. This one we're not going to factor by grouping. We're going to think of it kind of like the quadratics that we've already done this year. We're looking for the greatest common factor. Well, that's 4, and they all have an x squared. So I'll factor that out. That will give me x to the 4th minus 5x squared, plus 6. So now this factors just like a quadratic, even though it's not. I get x squared and x squared, and now I look for the factors of 6 that combine to give me 5. Minus 2, minus 3. And that is how we would factor that. That was quick. We'll start tomorrow with those. I don't want to keep you any longer. We're already over 10 minutes for these problems. So we'll pick up with these tomorrow.